In this video session, we will try to explore ANOVA with one example. Okay. So in our previous video, we discussed what is meant by ANOVA, and ANOVA, and how can we use, what are the equations we need to, what are the steps we need to perform on ANOVA to determine the test, to determine while utilizing hypothesis testing. Okay, so I hope if you are directly coming to this video, first I am suggesting you to watch the previous videos. So in this video we will try to see one example in ANOVA. For example, let's consider you have three locations X, Y, Z. Okay, in three locations you are running one business. You are running your own business, and you are manufacturing cell phones. Okay, in these three locations you are manufacturing cell phones. So you thought in one of the manufacturing site location we are building bigger size of cell phones compared to other locations. That is your claim basically. Okay, so let's, for example, imagine you took some samples from these three locations from from these three locations you took some samples, and then what is our claim? Our claim is we are creating bigger size of cell phones compared to in one of the site location. Then our null hypothesis is saying mu1 equals to mu2 equals to mu3. That means we are creating the cell phone sizes in all three locations are equal. That is what our null hypothesis stating, right? Then our alternate hypothesis saying that at least one location we are creating different size of cell phones, right? These are our null hypothesis and alternate hypothesis. Null hypothesis in three locations we are creating same size of cell phones. Our alternate hypothesis saying at least one of these three locations we are, at least one of the site location manufacturing cell phone sizes different from other locations. This is our problem. So now we need to find out whether this claim what we can say. We need to take a decision on this, right? To reduce the cost size for that business, we need to determine which assumption was true, whether null or alternate hypothesis, which one is true. So to do this, we are doing at confidence level 0.05. let's imagine. So first we need to know, as already I told you, we need to calculate all the things, grand mean as well as sample mean of each sample size, as well as degree of freedom, everything. So here degree of freedom of our total population is, that means k equals to, we are given 3, right? X, Y, Z. Throw 3 minus 1 equals to 2. Okay. So degree of freedom between groups, degree of freedom within groups, degree of freedom within groups, degree of freedom within groups equals to n minus k, right? N minus k, right? N minus k. That means what is our total sample size? Here 1, 2, 3, 4, 5, 6, 7, 8, 9. So n will be 9 minus k. K is already we know 3. That means 9 minus 3 equals to 6. So we know the degree of freedom between groups, degree of freedom within groups. So these two things will help us to find out the f alpha, right? F alpha equation, what is that? F alpha is degree of freedom between groups divided by degree of freedom within groups. That means 2 by 6, right? 2 by 6. So once you know this is the numerator, this is the denominator. Once you know the f alpha is what? Degree of freedom between groups by degree of freedom within groups, that is 2 by 6. So in numerator we have 2, denominator 6. Then in by seeing in statistics table, already predefined table, these will be available in net or any statistics books. You need to see what is our numerator? 2, right? 2. So our denominator is 6. So if you cross this to 6, our value is this one, 5.14. So by seeing statistics table, any one of the statistics table, F statistics table, you need to see F statistics table, you will get this value as 5.14. okay, this will be the our F alpha, right? This will be our F alpha, right? So as I already told, whenever you are dealing with some data, try to represent in distribution form. So this is our F alpha 5.14. So now the thing is we need to identify F value alpha, the probability of this, whether this is occurs here or here. If it is occurs here, whether F alpha is lesser than this value, then we will reject, otherwise we will accept. So till now, let me repeat once again. First we found degree of freedoms between groups, that is k, 3 minus 1 equals to 2. Degree of freedom within groups, n minus k, that is 6. So we calculated F alpha. F alpha is degrees of freedom between groups by within groups, that is 2 by 6. By seeing any statistics table, you can find this value by seeing numerator and denominator, that is F 5.14. okay, now we calculated this. Now second thing is we need to calculate grand mean, that is x bar. I already explained what is meant by grand mean. We will calculate grand mean. Grand mean is 1 plus, so we are given these sample data, right? 1 plus 2 plus 5, 1 plus 2 plus 5 plus 2 plus 4 plus 2 plus 2 plus 3 plus 4 divided by 9. Okay, so what is the value? 1 plus 2 plus 3, 8, 10, 14, 16, 18, 18 plus 3, 21, 25 by 9. 25 by 9. This is our, in our case, 25 by 9. 25 by 9, what is the value? You will get 2.78. This is our x bar value. So we calculated F alpha value. Second thing is grand value. Now we will move to, as per our previous discussions, we need to calculate SST, sum of square of among treatments or group SST. SST equals to what is the equation? X bar minus double x square plus n2 x bar 2 1 x double bar whole square plus n3 x bar minus x double bar whole square. So in this case x1 is the mean of first sample size. Mean of first sample size. So we need to calculate the mean of first sample size. Our first sample size is what? X1. 1 plus 2 plus 5. 1 plus 2 plus 5 by 3 equals to X1 equals to 2.67. Okay. In the same way X2. 2 plus 4 plus 2. 2 plus 4 6, 6 plus 2 8, 8 plus 3, that it leads to 2.67 around. X3 equals to 2 3 5, 5 plus 4 9, 9 plus 3 3. Okay, so these are our main values. Okay, now we will interpret in this SST equation. So our sample 1 n1 is 3, right? N1 is 3. 3 multiplied by x1 is 2.67 minus our grand bar value is 2.78 whole square plus second n2 is our second sample size is 3. So second sample mean is 2.27 minus 2.78 is our grand bar plus n3 is next sample size is 3. So next population sample size mean is what? Mean is 3 minus our grand bar x grand mean is 2.78 whole square. So this value, if you calculate, I calculated in Excel. Basically you can calculate in your own. Okay, this is the SST value. So we know how to calculate MST equals to SST by degree of freedom, that is k minus 1, right? So as we already know, 3 minus 1 is our degree of freedom. So 0.363 by 2 we will get 0.1815. This is our MST value. So once again let me explain. This is our problem area. We are given 3 pop samples in 3 locations. In our null hypothesis saying in all 3 locations we are manufacturing same size of cell phones, but our alternate hypothesis saying at least one of the cell phone size is different from another other 2 different locations. So we calculated what is the degrees of freedom within group is k, that is 3, populations minus 1 is 2, degree of freedom within group, that is n minus k. N is our total sample size, that is 9, minus 3 is our total population size 3, so we got 6. So we calculated f alpha. F alpha is degree of freedom between groups, that is 2, degree of freedom within group, that is 6, 2 by 6. 2 is the numerator, 6 is the denominator. By seeing our statistics, F statistics table, we calculated, we came to 5.14 is the F alpha value. Now after that we calculated grand mean. Grand mean is sum of all the sample size by the total number. That means 1 plus 2 plus 5 plus 2 plus 4 plus 2 plus 2 plus 3 plus 4 by n, that we got 2.78. Then we calculated SST. SST equation is n1 multiplied by mean of first sample minus grand mean whole square. You need to sum up all these things. So this is the once I represented 3 is the first sample size. Okay, 3 is our total 3 sample size. 3 multiplied by 2.67 is our first sample mean minus our grand mean. grand mean is 2.78, sorry, 2.78. So plus 3 n2, sample size, second sample size 3, our mean, second mean is 2.67 minus our grand mean 2.78 plus next n3 is sample size of our next sample 3 multiplied by our next mean, sample mean is 3, so 3 minus our grand mean is 2.78 whole square. If you calculate this, we will get 0.363, and once you know SST, we will know MST by divided by SST divided by degree of freedom, that is k minus 1. So 0.363 divided by, we know already 2 is our degree of freedom between groups, so we got 0.1815. Now we need to calculate SSE. SSE is ultimately what we will do is, we need to, from each sample, this is our first sample, right, 1 2 3, and we know the sample mean, first sample mean is 2.67. So we will, what we will do is SSA, what we will do is, what we need to do, our xi, first one is 1 minus, what is our first sample mean, 2.67 whole square plus second number, what is our second number, 2 minus 2.67 whole square plus our, what is our third number, 5 minus our sample, first sample size is 2.67 whole square plus, we need to repeat for same all the samples. Now we are moving to second sample. In second sample, first element is 2 minus, we need to consider our second sample size mean is 2.67 whole square plus our, move to second number, 4 minus 2.67 whole square, you need to repeat this, plus third element is again 2.67 whole square plus, now we are moving to third sample. In third sample, first element is 2, so 2 minus our third sample mean is 3 whole square plus second element is 3 minus our sample mean is, third sample size mean is 3 whole square plus our third element is 4, right, 4 minus 3 whole square. So once you done this calculation, we will get SSE is 13.6. Okay, so we got SSE. Now once you know SSE, we know how to calculate MSE. Now MSE is what? SSE by n minus k, right? This is our degree of freedom. So we know SSE is 13.6 by n minus k is what? 6. N is 9 minus 3 population, so 6. So we got around 2.26667. This is our MSE. So we know now MSE as well as MST, right? MST is 0.18515 as well as MSE is 2.2. So once you know, we know how to calculate F value, MST by MSE. That means we know MST is 0.11815 divided by our MSE value is 2.26667. So we will get 0.08073 529, like this, some number 0.08. So now we comes to end, we know the value of f, and if you remember in starting of our problem we calculated f alpha, right? So f alpha, we know f alpha is what? 5.14. So now we know the value of f also. F is 0.08. That means this value 0.08 value or f value will somewhere here, not in this extreme. Okay, what it's saying, our f value is less than our f alpha, right? Our f value is 0.08 is less than our f alpha 5.14. Okay, so if you know this, as per our f statistics, we can, if f is less than f alpha, then we will reject, we are failed to reject our null hypothesis. That means in all the locations, 3 locations, we are manufacturing same size of cell phones. So we got less f value compared to f alpha, then we are failed to reject. That means our f falls under this area, not under this area. If our f value falls under this area, we need to reject. If our f value falls under this area, we are failed to reject our null hypothesis. So in our case, our f is 0.08. That means if our mean is 0, that means our f will be in this area, not in this area. So we are unable to fail to reject our hypothesis. That means we are accepting our null hypothesis. Hope you understand our example. To better understand, once again I am repeating. So we are given 3 populations. That is, in our 3 locations we are manufacturing cell phones. Okay, and our business team asked us to determine whether we are manufacturing same size of cell phones in all locations or not. So here location is the factor, right? So first we need to define what is our null hypothesis and alternate hypothesis. Our null hypothesis says in all the 3 locations we are manufacturing same size of cell phones. Our alternate hypothesis saying at least one location we are doing different size. So first, to do this, as we are dealing with multiple populations and multiple variances, we need to go with ANOVA. So in ANOVA we need to perform some steps before coming to f and f alpha. F alpha sometimes we can determine as f critical value also. So we need to determine what is the degree of freedom between groups. That is, population size -1 will be 2. Then we need to determine within groups, degree of freedom within groups, that is n minus k. Our total sample size count is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 3 is 3. So by f alpha is degree of freedom between groups by degree of freedom within groups. That is, numerator is 2, denominator is 6. So you, by seeing in statistics table, f statistics table, you need to see f statistics table in statistics books or internet. You can find f value, f alpha value or f critical value. That is, we got 5.14. Now to calculate the f value, you need to identify what is the grand mean x bar. You need to sum all the values by divided by total number. You got 2.78 value as grand mean. Once you know the grand mean, then you know how to calculate SST, square of sum within group treatment or groups. So this is the equation n1. So you n1x mean of first sample minus grand mean whole square plus mean of second mean grand mean. Like this you need to go on all through all the mean samples basically. So we calculated sample mean of each samples. First sample is mean is 2.67, second sample mean is 2.67, third sample mean is 3. So interpret all these values, grand mean as well as our means in this, you will get SST. SST is 0.363. Once you know SST, we know how to calculate MST. MST is equals to SST by degree of freedom, that is k minus 1. So in our case 0.363 by divided by degree of freedom 2. So we got 0.1815. Once you know MST, then you need to calculate SSE. SSE is, once you know the sample means, you need to minus each and every element from each sample and whole square plus. So in this case 1 minus our sample mean of first sample is 2.67 plus second element 2 minus second sample mean of first sample is 2.67 whole square plus third element is 5 minus 2.67 whole square. This is first sample and you need to perform all for all the samples. Once you calculate, you will get our SSE. Our SSE is 13.6. So once you know SSE, we know MSE. MSE equals to SSE divided by n minus k. So in our case, degree of freedom is n minus k. N is 9 minus k 2. C 3 is so 6. So we got MSE. Once you know MSE and MST, you know how to calculate F. F is MST divided by MSC. That means we got 0.80. So we know the F alpha. F alpha is F5.14. Now we know the F value is 0.08. Now we need to determine whether this value is greater than alpha or less. In this case, our F value 0.0 is less than 5.14. That means our F falls under here. So when F is less than F alpha as per F statistics, we can say we are failed to reject our null hypothesis. That means we are saying in our all three locations we are manufacturing same size of cell phones. So in this way you can give your explanation, you can give your decision interpretations to the business so that business people can take any decision on that. Hope you understood properly, and once again I'm repeating, don't worry about these calculations, but you should know how we are doing and how we are taking a decision. This is the important point, how we are taking a decision, hypothesis testing, so that when you perform these all equations through programming language or through Excel, you can easily, once you know these values, you can easily say you can reject or fail to reject our null hypothesis.